Okay, so taking what we learned in 8.1 as far as solving quadratics by factoring, we're going to apply that to now what we call projectile motion. So projectile motion is any object in simplistic terms that gets launched into the air. And so on a simple term, it will follow that path, which if we remember back from semester 1, that is a parabola, which we then know is a quadratic equation, and projectile motion follows this equation here. H is the height of the object at any given time of t seconds. V is our velocity. S is our starting height. So sometimes we may have to substitute values in for those. And then T is our time in seconds. And then this -16 is the gravitational pull. So it's working at -16 on it when we're dealing with feet. If we're in meters, then that becomes a -9.8. All right, so let's look at number 1 here. It says a golfer takes a swing from a hill 20 feet above the cup with initial upwards velocity of 32 feet per second. How long does it take the ball to land on the ground near the cup? So let's label what we have. So important information, a golfer takes a swing from a hill 20 feet above the cup with initial upwards velocity of 32 feet per second. So then as we go to label all that stuff, our height, which is our final height, we have our velocity, and then our S, which is our starting height. So let's go in order. So our starting height is 20. Our initial velocity is 32. And then our final height, if we're on the ground, that final height is then 0. Everything's measured from that ground ideal. So as we look at that, substituting those values in, we get 0 equals -16 t squared plus 32t and then plus 20. Now from here we want to solve. Remember, all our steps and process is the same at this point. So then we look for what is our GCF. So we get 4. And so we come back over here. I'm going to factor out a 4, but since we have this negative here, I want to pull out that negative as well. So we get a -4, and that gives me a positive 4t squared minus 8t minus 5. Now from here we can factor what's left in the middle. So as I do that, we'll go our x. So I get a times c, which is a -20. And then bottom we get a -8. So what multiplies to -20 and adds to -8? So that gives us a -10 and +2. And then our box. So we get 4t squared, -10t, 2t, and then a -5. Then we look for our GCF. So I get a 1 there. I get a 2t there. a 2t there, and a -5. So we get -4, and then that became 2t plus 1, and 2t minus 5. And that is then set equal to 0. Now to solve, we're going to take each of those, set them equal to 0. So we get -4 is equal to 0. 2t plus 1 is equal to 0. And then 2t minus 5 is equal to 0. Well, -4 will never equal 0, so that does nothing for us. Here we're going to solve, so I'm going to subtract 1. And you get 2t equals -1. Divide by 2. And t equals -1/2. Over here we're going to add 5. And we get 2t equals 5. Divide by 2. And t equals 5/2. Now as we look at those, remember t is talking about time. So can we have a negative time? That is a no, so that doesn't make sense to us. So then t equals 5/2, but we don't talk about, oh, I did something in 5/2 seconds, so we want to convert that to a decimal. So then our t for this problem is going to be our time equals 2.5 seconds. Okay, so let's look at number 2 here. It says a skydiver jumps out of a plane has initial velocity of 60 feet per second. Downwards, how long does it take to fall from 1,000 feet to 900 feet before the parachute opens? So let's look at our values here. So we have h, which is going to equal our initial, or our final height we want is 900. Our velocity is going to be a -60 because we're going down. And then our starting height is 1,000. So as we plug all that in, our h is 900. And that equals a -16 t squared minus 60 t plus 1,000. And again, look for our GCF. And so our GCF on this, we can't quite do yet because on all of these, we need to have it set equal to 0. So I need to subtract this 900 first. So then we get -16t squared minus 60t plus 100. So our GCF there, number-wise, is going to be 4. And then like last time, since we have a -16, we're going to plot that -4. So then that gives us a positive 4t squared. It gives us a positive 15t, and then a negative 25. So then let's factor. So I get negative 100 when I go 4 times 25. And we get 15 down here. So it multiplies the negative 100 and adds to 15. So it's going to be a positive 20 and a negative 5. So let's go ahead and box. And we have 4t squared, 20t, negative 5t, and then negative 25. And then find our GCF, so we pull those out. So I get a negative 5 there. We get 4t there, just t there, and 5 there. So then bringing that over, we have 0 equals a negative 4, 4t minus 5, and t plus 5. Solve. We already saw that 0 and negative 4 doesn't do anything, so then take the factors with a variable in it and set them equal to 0. So when I solve, add 5, and you get 4t equals 5, divide by that 4, and t equals 5 over 4, or 1.25. Here we're going to subtract 5. You get t equals negative 5, but we're not going to deal with time in negative seconds. So then our answer for this is going to be t equals 1.25 seconds. All right, so I want you to work on number 3 on your own, and we'll talk about that one in class.